So continuing our notes, we can see that in example 5, we can factor this as a difference of squares as well. But the important part here is that we're going to need to factor something out before we can find our difference of squares. In this case, 36 and 25 don't seem to have any factors in common, so we can factor out a y. So if we factor out a y, we're actually left with 36y squared minus 25. Now this becomes easier because now we can find our difference of squares. So we're going to rewrite this as 6y to the power of 2 minus 5 to the power of 2. And so now we have our difference of squares where we have y, and then we're going to put 6y plus 5 times 6y minus 5. So we had to take that extra step of factoring out something before we could have our difference of squares. Same situation with example B. Now, 80 and 5 aren't necessarily perfect squares, but if we factor out a 5, we can see that 80 divided by 5, that would be 16y4. And then 5 divided by 5 would give us a 1. Like that, the 1. So now that seems like a reasonable perfect difference of squares. We can rewrite this as 4y squared to the second power minus 1 to the second power. So 4y squared plus 1, and 4y squared minus 1. Now, last example, number 6. Now it looks that because of that plus sign, we wouldn't be able to find the difference, but we have a negative at the front of 9, so we can actually factor out that negative. We would be left with 9x squared minus 100. Now, this is something that we can rewrite as a difference of squares. So we can say this would be 3x to the power of 2 minus 10 to the power of 2. So we end up writing our answer as 3x plus 10 and 3x minus 10, with that negative on the outside.